Pre-Calc 12, Chapter 6.6. We're going to be combining transformations of sinusoidal functions. So the general form, again, is a f of b x minus c plus d. We're going to learn three different methods of plotting. You choose the way you like the best. Now, I'm going to say this is probably the easiest method, and it works because of periodicity. So just follow these steps. Plot the center line and make it a dotted line. Plot the max and min, make it a dotted line. Just add line here. Transform the y-intercept of the trig function, 0, 0 for sine, 0, 1 for cosine. Plot the periodic points for the y-intercept. Then halfway between the periodic points, plot on the center line for sine and plot on the minimum line for cosine. Sounds tricky right now, but it'll make sense in a minute. And halfway between the points on point 4, plot the max, then the min for sine, and plot the center line for cosine, and then join the points smoothly. Okay, we're going to do a cosine transformation because we've seen a lot of sine transformations. So, step 1, plot the center line. The center line is at 2. This is 2, 4, negative 2. So 2. Draw a dotted line. Okay, the amplitude is 3. So we want to go 3 up from the center line and 3 down from the center line. And again, we're going to just make it a dotted line. And 3 down takes us to negative 1. Okay, next, transform the y-intercept. Okay, we're going to go pi over 4, and cosine is at the maximum. There's 4 grid units for pi, so we're just moving 1 grid unit. So we're transforming our maximum there. And step 4, plot the periodic points. So our period equals 2 pi over 2, and that's just pi. So pi is 4 grid units, 1, 2, 3, 4. And we can just keep on plotting these, 1, 2, 3, 4. Now, halfway between these periodic points, we're going to plot the minimum because we've already plotted a maximum. So 2, we've got a minimum. 2, we've got a minimum. 2, we've got a minimum. Other way, 2, we've got a minimum. And then we can just go 1, 2, 3, 4 as well. Now, halfway between the points that we've plotted in step 4, which is this point, this point, this point, this point, because we've only got a spacing of 2, it's going to be a spacing of 1. We are going to plot the center line. So every 2 units is going to be the center line. Okay, and now we can just join the points smoothly. So up, down, down, up, down, up, down, and then we can stop there. And down, up. Make sure these peaks are curves and not corners. And we can stop there as well. Okay, I think that was pretty simple. If you're comfortable doing it that way, go ahead and do it that way. And the next method is just like the previous one we've learned. We can perform the scaling and flipping first, then apply the shifts. And again, order is important. And we're just going to do exactly the same example. That way you can compare the two. Okay, so we need a vertical scale and a horizontal compress. So vertical scale of 3, horizontal compress of 1/2. So that goes to 3. This stays at 0, but we're compressing horizontally. So I'll just draw arrows of what we're doing here. This is going to move this way. This one is going to stretch by 3, compress by 1/2. So that one's going out that way. And we only need to draw one cycle. Expands to 3, compresses to 1/2, and we draw this cycle. Okay, now we can do our translation. Right pi over 4 up 2. And let's do this in a different color. We'll do this in green. So right pi over 4, that's 1 grid unit, up 2. Right 1, up 2. Right 1, up 2. Right 1, up 2. Right 1, up 2. And we can just draw this cycle. And then continue the cycle. If you can do it without plotting the extra points, that's fine. Otherwise, if you need the points as a guide, I suggest you draw them. And we're done. So if you like that method, just draw one cycle, transform that one cycle, and extend the cycles. Now, option 3. And I would argue that this is probably the hardest method, is just doing the table of values. Now, you are still doing the same transform. This is x over b plus c, and we're going to do ay plus d. And again, do one cycle's enough. We transform, and we're doing exact same transformation. And let's put this formula down. So the transform is we have x over b, that's 2, plus pi over 4. And we have a, that's 3, y, and then plus 2. So we take our first point, negative pi over 2 plus pi over 4, 3 times negative 1 plus 2, and we get negative pi over 4. We have to have a common denominator. We multiply this by 2 over 2, so we get negative 2 pi over 4. Add that to pi over 4. Negative 3 plus 2, that's negative 1. Negative pi over 2 divided by 2, that's negative pi over 4, plus pi over 4. 3 times 0 plus 2. These cancel out, we get 0. 3 times 0 is 0, plus 2 is 2. And 0 plus pi over 4. 3 times 1 plus 2. This gives us pi over 4 and 5. Pi over 2 divided by 2, that's pi over 4, plus pi over 4. 3 times 0 plus 2, that's pi over 2, and 2 again. And one more will complete the cycle. Pi over 2 over the 2 plus pi over 4. 3 times negative 1 plus 2. Again, multiply by 2 over 2. We have 2 pi over 4 plus pi over 4. That's 3 pi over 4. Negative 3 plus 2. That's negative 1. And if you plot these, Here's our original. Plot point 1. We have negative pi over 4, negative 1. So this point's going to there. Number 2, we have 0 and 2. That's here. So this point is going up to there. And for point 3, we have pi over 4 and 5. And for point 4, we have pi over 2 and 2. And for point 5, we have 3 pi over 4 and negative 1. So we plot our cycle. And just like the last one, we extend our cycle. Again, it's up to you whether you want to draw your guide points. And that's it. So choose between the 3 methods, whatever you like the best, or whatever the one gives you the least amount of errors. One more last task. We need to determine the transformation. And unlike what we've done before, you do not have to do full algebra for this. And again, it's because of the periodicity. You can just calculate d min plus max over 2, or the average. We can calculate a max minus d, or we can also use max minus min over 2. Calculate the horizontal scaling. We have b equals 2 pi over the period for sine and cosine. And calculate the phase shift. Look for where y-intercept has moved. Now, I will say that it's customary to do a positive C for your phase shift, just because that's what most people are used to. But on the rare occasion, you can use a negative C. Okay, unfortunately, the graph has been erased. You'll have to draw this out. So we have 3 pi over 4, negative 1. We have 3 pi over 2, 1. We have 9 pi over 4, negative 1. And we have 3 pi and negative 3. On this side, we have 0, negative 3, and we have negative 3 pi over 4 and negative 1. So we have something that looks like this. Okay, we look at the max and min, and we can determine our center line. So you can visually spot the center line. Or you can go ahead and do the calculation. D equals 1 plus negative 3 over 2. This is negative 2 over 2, and this is negative 1. And visually, we see that this is at negative 1. Our amplitude, we can do our max minus the center line. A equals max minus the center line, and that's 1 plus 1, and that's 2. And we'll measure the period. The period is very convenient to measure from here to here. That's 3 pi. So B equals 2 pi over 3 pi, and we just get 2 over 3. And our phase shift. This is a sine curve, so we want to look at where the 0 moves. So the 0 moves from here to there. And that's 3 pi over 4. Okay, and then we just have to write out our function. Y equals A, that's 2. Our curve is a sine curve, so don't use F. If you're given sine, use sine, not F. Our B is 2 over 3. X minus our shift, that's 3 pi over 4. We have 1, 2 left brackets, so we need 1, 2 right brackets. And then we add our center line, which is -1. And that completes this lesson.